video, we will be looking at linear programming with a marketing mix problem. So for this, we need to have the solver. So if you need to add the solver, look into the video and how we added the data analysis button. The solver is within that same pop-up screen. So that will help you get the solver. If you have any questions, reach out to me and I'll talk you through it. But everybody's computer should have it. So we have a marketing mix problem where we want to maximize the exposure quality units and refer to the PowerPoint if you want more background on this case. But I'll recap it here as best as I can. This is found on the linear programming tab on the Excel sheet from week 3. And we have number of potential customers reached, cost per advertisement, maximum times that an ad can be run per month, and exposure quality units, which is made up of demographic information, income, it's marketing stuff, and I'm not a marketing person, so I don't even know if that's a real term, but exposure quality units is what we're going with for this example. There's variable cells, and what these do is if you manually input things into here, you'll notice some things change. You have this, which is our objective function, which was what we're trying to solve for. This increases or decreases based on those variable cells changing. But this gives us our number of exposure quality units. Total reach is here, and it's just a function of the variable cell times the number of potential customers reached. You've got a sum of that here, and there's a total ad cost. Same thing as total reach. It's a function of how many times are you running the ad, which is what the variable cells is simulating. This is simulating you're running this evening TV ad 4 times. You'll notice this measure is total TV spend. The case wanted to make sure that we spent under $18,000 on TV ads, so this helps us capture that with a formula. And there's TV runs. The case specified they wanted to do at least 10 television runs. And our objective function is here, we're solving for total quality units. So let's actually look at the solver. And this template actually pre-populates this data. So that's good for you, but it's less learning that way. But let's look at the objective function. Well, we set the objective to be B8. We want our objective to be maximize the exposure quality units. So B8 is our formula with our objective function. So great, that makes sense. We want to maximize it. We're going to change the variable cells of G2 to G6, which are these little fellas. So those get modified by the formula or by the solver, and it just iterates through every possible combination. That's pretty cool. Total reach, it's a sum of this column. Total ad cost, sum of this column, and I showed you the TV spend. And these are shown here. So these are called our constraints. And here's a constraint. G2 should be less than or equal to D2. So G2 is this, and it should be less than or equal to D2. We don't want to do more than 15 ads per month. And so you'll do that for all of the variable cells in G and compare it to D. Now here is, we got tripped up in class over this a little bit, but here's H7, which is our total reach. We want that to be greater than or equal to 50,000 eyeballs seeing this ad, which is what the case specified. So that's what that's telling us. But you put these constraints in, and you're going to hit solve, and it is going to tell you that our maximum total exposure quality units is 2370, and that's based on running 10 daytime TV ads, 25 website ads,